Hello friends, today we'll be discussing hypertrophic obstructive cardiomyopathy, the effect of genetic hypertrophic obstructive cardiomyopathy. As we know, is produced by genetic mutations in 9 genes, which has over 1400 mutations. So there's varied effects are seen on the heart. Now, these effects are on the myocardium, that's myocyte hypertrophy is there, and there is disorganization which is known as disarray of the myocytes. Similarly, this is produced by sarcomeric hypertrophy because most of the genes, they affect the sarcomeres and lead on to the hypertrophy, and they also get disorganized, and this is known as disarray. And in addition, this is also associated with a lot of biochemical processes. That the calcium flow occurs, there is hypersensitivity to the calcium, there is increased ATPase activity which leads on to hypercontractility. Apart from the effect on the myocytes and sarcomeres, there are a lot of changes occur in the intercellular matrix as well, which leads on to hypertrophy by virtue of the fibroblast proliferation and transformation of few of the myocytes to fibroblasts, and these result into fibrosis and scar formation. Now, the small vessels also get hypertrophied, and so much so that this occlusion occurs which leads on to the ischemic changes and scar formation. Now, these phenotypic expressions are in the form of left ventricle outflow obstruction, and when the heart contracts, this leads on to the mitral regurgitation. Because of this intercellular matrix and scar formation, there is increased sensitivity to ventricular arrhythmias which produce ventricular tachycardia, syncope, ischemic changes resulting in chest pain and congestive cardiac failure. Let's see these processes one by one. That apart from the myocyte, there are changes in the fibrous tissue, that's intercellular matrix, which result in the formation of myofibroblast, fibroblast, and increased fibrous tissue in the interstitium. Now, as there is small vessel hypertrophy, intramyocardial vessels, they get hypertrophied, resulting into decreased lumen, and which produces ischemic changes and the fibrotic changes, which set a stage for the production of ventricular arrhythmias. Now, these processes are also associated with increased ATPase activity, which results in hypercontractility, and this is one of the biochemical processes which increases the ventricular contraction, and in fact the force of contraction of the myocardium. The basic process with which we are all familiar is the cardiac myocyte hypertrophy. So there is increased thickness of the sarcomeres, which occurs in more than 60% of the cases. So there is myocyte hypertrophy, and there is disorganization of the myocardial fibers, because if you see the normal pattern of the myocardium, which is in the streamline process, they get branched also, but the organization remains very smooth. But here the organization is disturbed, and this is known as myocardial disarray. All these processes lead on to the structural changes in the myocardium with which we are all familiar, that is, there is hypertrophy which can also produce obstruction in the left ventricle outflow tract. So if we see the contraction of the left ventricle, which pushes the blood into the left ventricle outflow tract and into the aorta, because of this flow of this blood through a contracted left ventricle outflow, there occurs the movement of the anterior mitral leaflet, which is known as systolic anterior motion. So this further increases the obstruction to the left ventricle outflow, which produces systolic murmur. Now, because of this movement of the anterior mitral leaflet, the separation from the PML occurs, and this produces mitral regurgitation. So this mitral regurgitation is not because of any defect in the mitral valve, but because of the suction effect of the blood flowing through the left ventricle outflow tract, which causes suctioning of the anterior mitral leaflet and produces left ventricular outflow tract obstruction and also mitral regurgitation. So this is the phenotypic expressions which occur. The left ventricular outflow tract obstruction, there is mitral regurgitation, and there is scar formation if the left ventricle, which produces congestive cardiac failure. So ultimately, if we see, what happens is there may be ischemic chest pain with exercise, and there may be embolic phenomena because this myocardium is prone to various arrhythmias, ventricular arrhythmia as well as supraventricular arrhythmias also, which can lead on to the embolic phenomena. And the arrhythmias, they go on to produce the ventricular tachycardia, and ultimately sudden cardiac death is one of the important manifestation of this kind of problem, that's the hypertrophic obstructive cardiomyopathy. Thank you.